Hello. Yes, we welcome you back to PSSB with me, Richard, here. And here comes the question. It says, draw Lewis diagram for each of the following. And the first one is nitrogen. How do we deal with this one? Okay, this is what you have to know, that nitrogen belongs to group 5 or 15 for some people. So group 5 has 5 valence electrons. So how do you distribute them? This one takes 1, 2, 3, 4. Then you start pairing 5. What does this mean? It means that nitrogen has 3 unpaired electrons and 1 lone pair. What is the implication of this? It means that nitrogen has the capacity to form 3 bonds. Okay, suppose you have another one of the same kind, having the same distribution, which is 1, 2, 3, 4, 5. Then what is going to happen? What is going to happen is that these 3 unpaired electrons of one nitrogen atom, they pair up with the 3 unpaired electrons of another atom, forming something like this, having nitrogen, where one contributes this, and that. And then another nitrogen atom comes, contributing this, that, and that. You have to remember that each of the nitrogen atom has 1 lone pair, so we indicate it there. So if you look at each nitrogen here, you realize that it satisfies the octet rule. It has 8 electrons. These are 6 plus 2 is 8. The same applies to the other one. It has 6 plus 2, which is 8. So that is it. What you have here is the nitrogen molecule, which we indicate structurally as nitrogen with a triple bond between them. Yeah, then we come to oxygen. Okay. Yeah, we have to know that oxygen belongs to group 6, which some people call 16. Okay. So that means that if you have an oxygen atom like this, it has 6 electrons around it. And how do you distribute it? We can say 1, 2, 3, 4. Then there are 6. So start pairing 5, 6. Now, this one shows that oxygen has 2 unpaired electrons, meaning that oxygen has the capacity to form 2 bonds. We need to remember that bonding occurs between unpaired electrons. The paired ones cannot form bonds, unless in special cases. So let us look at another oxygen atom. It comes and it has the same electron distribution, which is 1, 2, 3, 4, 5, 6. So what is going to happen here? What is going to happen is that the 2 unpaired electrons of one oxygen atom bond with the other one. So what are we going to have here? We are going to have oxygen atom, and the two unpaired come here for bonding, and you have another oxygen atom, and the two unpaired are here. But you have to remember that in addition to the two unpaired, oxygen had two lone pair, which we indicate here. Okay? The same applies to the other one. It has its two lone pairs. So this is the Lewis diagram of oxygen molecule, which structurally we represent as O double bond O. Okay. Let us now observe each oxygen atom. It satisfies the octet rule, surrounded by 8 electrons. Because in this one, these are 4, plus this 4 is 8. The same applies to the other one. Because these ones are shared, so they belong to each atom. So this one has 4, plus this 4 is 8. That's what makes it stable. Yeah, then comes this one. This one is called hydrogen cyanide. And how do you go about it? It is very clear here that the central atom is carbon. So we can have it. We can have our carbon. And what do we know about carbon? It belongs to group 4 or group 14 for people who believe in the other version. So group 4 has how many valence electrons? 4. So we can have 1, 2, 3, 4. What is the implication here is that carbon has the capacity to form 4 bonds. You have to know that each unpaired electron reflects the potential to form a bond. Okay? Then we have this side hydrogen. So our hydrogen will come here. And remember, it has that 1 electron. And we come with our nitrogen. Okay, we have to know that nitrogen belongs to group 5 or group 15 for people who believe in the other version. So group 5 has 5 valence electrons, meaning that you have 1, you have 2, you have 3, you have 4. Then pairing starts with this. And what does this mean? That nitrogen has the capacity to form 3 bonds. Remember, each unpaired electron is indicative of ability to form a bond. So now comes for rearrangement. What is going to happen? Remember, this one, the central atom has the capacity to form 4. So what is going to happen is that 1 will bond with this one, remaining with 3, which will bond with these 3. So if we put our arrangement, we are going to have our carbon, and we represent our hydrogen. So what does this mean? That carbon still has more 3 bonds to form. It has used 1. So the 3 will bond with nitrogen. So what are you going to have here? We are going to have 1, 2, 3. Okay. And the nitrogen comes with its 1, 2, 3. But don't forget that nitrogen has a lone pair somewhere, so we indicate it there. So this is it. What you see here is the Lewis diagram for hydrogen cyanide. And we need also to know that if you indicate it structurally, you are going to have H, C, triple bond N. Yeah. Then comes this one, carbon dioxide. Okay. How do we go about this? It is clear here that the central atom is going to be carbon. So we have it. Then the question comes, what is the valence electrons for carbon? Carbon belongs to group 4 or group 14. And it has 4 valence electrons. And the 4 valence electrons, each indicated in the corner, means that carbon has the capacity to form 4 bonds. Okay? Then if you look at our oxygen, there are 2 oxygens involved here. 1 oxygen is here and 1 oxygen is there. Okay? And oxygen belongs to which group? Group 6. So if you distribute the electrons, what are you going to say? It's 1, it is 2, it is 3, it is 4. Now remember it's 6, so it's 5, it is 6. What does this show? This shows that oxygen has 2 unpaired electrons. So oxygen has the capacity to form 2 bonds. So we can do the same thing that side. Okay? We can say it's 1, it's a 2, 3, 4, 5, 6. So this is the situation we have. The central atom has 4 possible bonds which can be formed. Meanwhile, this oxygen has 2 possible bonds, and this one has 2 possible bonds. That implies that there is going to be rearrangement where the 2 of carbon will bond with 1 oxygen, and the remaining 2 bonds with the other. So if we rearrange, this is what we are going to get. We are going to get our carbon, and the 2 bonding electrons come that side to bond with 1 oxygen, and these ones come this side to bond with that oxygen. Then oxygen comes, brings its 2 unpaired, and like that. And also here, it brings 2 unpaired, and like that. But you have to remember that oxygen has 2 lone pairs, so you have to indicate them. This is 1, 2, 1, 2. This is 1, 2, 1, 2. So that is that. What you have here is the structure of carbon dioxide. This is the Lewis diagram of carbon dioxide. If you indicate the structure, it's going to be carbon, double bond, oxygen, double bond, oxygen. This is the structure of carbon dioxide. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, we urge you to subscribe, to comment, to like, to share. And also we need to remind you that Physical Sciences Silver Bullet is a YouTube science channel specializing in physical sciences grade 12, 11, and 10, and natural sciences grade 8 and 9. Yes, we advise you that if you are using the channel, please go to playlist, not video. This is This is a channel with a very wide scope. So we have tried to arrange material for you in the playlist. For grade 8 and 9, just look for Natural Sciences grade 8 or Natural Sciences grade 9. For grade 11 and 10, look for Physical Sciences grade 11 or Physical Sciences grade 10. As for grade 12, every chapter has been presented independently. So just look for the chapter of your interest and click on the title of it. Yes, we appreciate your time. We cherish you. Yes, see you next time. Bye-bye.